Hello everyone, good evening.
Good
My,
evening.
na- my name is Omkar Joshi and I'm course instructor for computational thinking. And I will be conducting today's Solve with Us session, which is for week 9, which is the place where we started with graphs. So as more people are joining, maybe we'll start in another 2-3 minutes the actual session, which is Solve with Us. So before that, if you have any general queries or something, some quick queries, then maybe I can take those in next 2-3 minutes. Not specific to this graded assignment question, that practice assignment question, not those kind of queries. In any general queries related to the course or some or program,
Sir,
then yeah.
I had a
Sir,
suggestion in the course.
You had Abhinandan, can you repeat?
So, like, I have a suggestion for the course.
Yeah, sure, go ahead.
So, like in every assignment, we solve the question, and
Mhm.
next time, like if we refresh the page, the assignments, so suppose I have completed an assignment. Let us
Mhm.
say activity 1.
Yeah.
So I had a doubt in question number 3.
Mhm.
I wrote that in my paper. So,
Okay.
but like in like doubt clearing sessions, when I have to like see which question I had doubt,
Mhm.
I have to search for paper. So
Okay.
my suggestion was like instead of like in a portal itself, there should be an option of flagging. Like
Okay.
if I have a problem in a question, I will just star mark that question, so it will be
Uh-huh.
reflecting in my portal only. Like whenever
Okay.
I
So at your level, you want to flag a specific question. That's
yes
your
sir, yes sir.
okay.
So
Okay.
it will be great while revision also, that we can see which
Okay.
questions I had doubt. Nothing
Okay,
else.
sure. Sure. Let me, I'll convey this to the portal development team.
Yes,
So let them figure out whether it's possible, and if so, then let them implement it. Okay.
yes sir.
Yeah, that's a good suggestion. Or maybe in meantime, maybe you don't have to every time wait for live sessions to happen, right? You can always
Yes sir.
post your question on the forum. You know that, right?
Yes sir.
Okay. Yeah. Okay, fine. So yeah, somebody else was saying something.
sir, could you help? I just wanted to visualize how the data is stored in matrices. Like I couldn't visualize
Okay.
that part.
Okay, that's something anyway we'll do now. Just a quick answer to your question. See, in matrix is nothing but what you have studied in from school days, right? It's a tabular structure. It's a two-dimensional entity, right?
Sir, I get what is a matrix. I'm
Yeah.
not getting the part like
And
it's a nested
I'm coming to
dictionary.
that. I'm coming to that. So over here we are creating a nested dictionary, right? So at top level we have a dictionary. Let's say our matrix is of size 5 by 5. Okay.
Okay, sir.
Then we have a dictionary, and in that dictionary we will have keys from 0 to 4. 0, 1, 2, 3, 4. Right? Those will be the keys. Against those keys there will be another dictionary. Okay, and that inner dictionary will again have the same keys, 0 to 4. So that all inner dictionaries will have those keys, 0 to 4. And that is how you can access 0, 0, 0, 1, 0, 2, and so on.
So, sir, initial dictionary keys are stored in column and internal dictionary keys are stored in rows or vice versa.
No, it's better to consider it other way around. The outer dictionary is rows and the inner dictionary is column, because that's how usually we read a matrix, right? First row, then column, right?
Okay. So outer
When
one is
when
rows
when, when
and
I
inner one.
say when I say let's say M is a matrix, M of 2, 3, then row number 2, column number 3. That's how we usually read it, right? So
Sorry,
the
sir, could you
first,
repeat the last statement?
yeah. So if we say M of 2, 3, right? M of in bracket 2 in bracket 3, then
Yes,
that
sir.
means row number 2 and column number 3. That's how we usually read it in most of the times, right?
Okay, it's RC then.
Yes, it's RC, correct.
Okay.
Yeah. Okay, so it's already 8:05:86. So yeah, now let's start with the actual today's session. We'll come back to your general doubts if we have time towards the end. All right. Fine.
Okay, sir.
So let me share my screen. I assume you already are aware of this place called joinpd.com. I believe you all are aware of it, that peer deck website. So I've shared it. So you are all are supposed to join this particular website. Go to this website, joinpd.com, and insert or add these 6 letters as a code to join this particular this peer deck session. Okay, so 4 students have connected, 5. So everybody has to connect. So let me repeat. What you're supposed to do is just you have to go to this website called joinpd.com, and over there you have to add these 6 letters as a unique password or as a key or something, which will allow you to join this particular session. I can copy this. Okay, so I posted that in the chat box. So if somebody joins later on, you can help those students later on by keep posting it again and again. Okay, so we have 30 students, and over here we have 53. Come on, others. If there is any problem where you are struggling, please let me know. I will help you. I will guide you with respect to how you can join and all. Okay, just quickly, last 10 seconds. Join everybody so that we'll start the class. By the way, we get a log of who have joined, who hasn't joined on Zoom as well as peer deck. Okay, so I mean, not immediately, but maybe I can go back and check who joined and who did not join. So that record is always there. Anyways, fine. So let's start the class. We have some 40 plus students. Okay, so I hope you all are able to see the slides. I mean, yes, I have shared my screen, but in order to answer those, you will have to, access this on the peer deck itself. Okay, so it's better to look at the peer deck rather than what I have shared. Okay, so keep looking at peer deck, and if I'm explaining something or something of that sort, you can come here and look at what I'm doing. Okay, otherwise please focus on your peer deck side. I hope you all are on this slide, which says week 9 computational thinking, solve with us.
Yes, sir.
Yes. Okay. So let's start with this. Yes, let's start with problem 1. So first, let's look at this particular table. This is not exactly our course data set, but data is different and some subset of data is there, right? Some sequence number, name, gender, date of birth, and CT. Only this information is there, and that too only for 6 students, and even the values are a bit different. Okay. So for next question, right, for problem 1, focus only on this particular table. Okay. Later on, you will require this information. I will come back to this slide whenever required. But just to give you a glimpse that this is what our data set is for only for problem number 1. Okay. And that is this table 1. Consider this as a table 1. Okay. So now read this question. First, read this paragraph, followed by this box below that, the left-hand side. And as and when required, you're supposed to call these procedures. I mean, over here, we have called that in first line, we are calling init dict, which is this procedure, and is related is this second procedure. So please read the whole thing. I will give you 2 minutes and then we'll move to the next slide. So you're supposed to solve this question. Okay, so have you all got the question? I mean, may not be the actual question, but have you gone through this pseudocode?
Yes.
A few more seconds.
Yeah, sure. Okay. Let's wait for a few more seconds. Okay, is everybody ready?
Yes, sir.
Okay, so what we are doing is just one table, and we have created a dictionary using this init dictionary procedure. And then we are doing something with this is related procedure over here. So that's our entire pseudocode, which is broke down into 3 different blocks. Okay. Now after this, this is your question, but just read this question. In order to answer this question, you might require actual values from the data set. Okay, so read the question, and then maybe if you are ready, I will go back to that table, which will help you understand this. And remember, it says not true. Okay, remember this. Don't forget this. Not true. Already some 6 students have responded. 7 out of 47 have responded.
Sir, could you show the graph?
Yeah, sure. So I will go back to this. No, graph is not there. This, I mean, the data is stored in this particular data is there. So this is not a generic question. Okay, the question is specifically based on these values. So using these values, you have constructed the dictionary, and as in dictionary, as in the dictionary which will help you to construct that matrix, which is nothing but that graph. So the question is actually about this A. Okay, the matrix A, which is nothing but the representation of graph. So remember, these are the values. Okay. So if you want to note down some values from here, please go ahead and keep a note of that or something. So these are the values which will help you in answering the question. Okay, so I'll go back to that slide so that you can answer.
Sir, please keep this slide, sir.
Yeah, yeah. Okay, I will stop sharing for a minute, but you will be able to see it on your periodic site, because I want to see what all responses I'm getting, which I don't want to share as of now. Okay. Some 20 responses are there. Most of them are on the right track. There are few who have submitted wrong answers, but most of them are on the right track.
Sir, can you please share the table, sir?
Yeah, sure. Is it visible?
No, sir.
Not my shared screen. It should be visible on your periodic site. Is it visible now?
Yes, sir.
Yeah.
Yes, sir.
Okay. So as I said, if you want to note down some specific values, please note them. Then only, I mean, unless and until I go to that questions last slide, you will not be able to answer it. So take a note of some required information. I mean, you all know that the entire information over here is not required, right? You require just only few details from here. So all good. Can we move back to question?
Yes, sir.
Okay. Okay, go ahead. Now you can answer this question again. So far, half of the people have answered it. Maybe a few more responses, then we'll see what people have submitted and what's the correct answer. You have last 30 seconds. All right, so out of this 50, some 35 odd people have submitted. So I think that's good enough data. So let me show you what all, now you can stop, stop responding and please focus on this shared screen. So that now we can go to the explanation and all the things after that. Okay, so the responses, let's see what this, how 34 is divided into. Okay, so as you can see, most of people have submitted option B, 18. And then there are some odd 7, 4, 5 for other options. Okay, so let's see whether which one is right and why and so on. Okay, it looks like the majority is towards this option number 2, which says in every clique there is at least a pair of students having different date of birth, which is not true as per what the your responses say. Fine. So let's move to next slide and see what's the explanation or the solution to this problem. So this is the first step. What we have to understand is a sequence number is used, to denote a node onto a graph, right? So this is, I mean, we'll go run through that particular pseudocode line by line. So the point to note is we have created a dictionary using that init dictionary. And then that's our first step. So what is happening in that dictionary? We are using that sequence number of a student as a key, and against that we are storing a list of these two entities, right? Date of birth and gender. So our dictionary will be a list of values, right? So it's a collection of lists inside a dictionary, right? The key will be sequence number because that's unique, and value is a list of two values. It's a pair, right? As we have studied in week 5. So it's a pair which stores two values, date of birth and gender. So that's our dictionary. Then we have got that n, we created a matrix. So we have n by n matrix. And if you remember our data set, that table had some 6 students, right? 6 or 5 some students. Yeah, six students. So our this particular dictionary, or no, this particular matrix, right, or the graph should have 6 nodes, right? It's a 6 by 6 matrix. So that's our second step. So before going to that second step, can you tell me which one of these is a is a correct or a valid element of a dictionary? We just saw that.
Option B.
Option B.
You can answer it here.
Option B.
B.
You have option, right? I mean, you can submit it on the peer deck. See, wherever you see this left side logo over here, right? That means it's a question on peer deck. You can submit the response there.
It is the next question.
Right, and now most of the people have submitted. As we know, it should be date of birth, comma, gender, right? So date of birth is here, followed by gender. So option B should be right. And let's see what people have submitted, right? Almost everybody submitted the option B. which is the correct answer here, right? So now you have understood how this dictionary is constructed. Now we can go to step 2. Okay, let's move to that. So this is what, I mean, that's why the answer is this. Okay, so finally our dictionary will look something like this. The full dictionary will look something like this, right? 0, date of birth and gender for 1, for 4, for 5, not 5, 2, 3, 4, 5. Okay, the whatever, the entire table now is converted into this dictionary. All right, all are with me?
Yes, sir.
Go all
Yes,
the
sir.
way to 29, no?
Sorry?
It will go to the all the way to the 29, right?
No, we have table with only 6 entities, right? This is not
Okay.
scores data set. We are focusing only on that small table.
Okay, got it. Thank you.
Yeah. Okay. So let's move to next part. So this is how the whole thing will be generated. I mean, we don't have to do it step by step, but in just to show you, right? We start with first, then we'll append 1, then we'll append 3rd, 4th, 5th, 6th. So one by one, the entities, these key value pairs will be appended to the dictionary D. Okay, this is something maybe later on for your reference you can use it. Right now we can skip that. That's very easy. Okay, now the important part is step 2, which is that second procedure, which is related, right? So in related, what we are passing, D of I and D of J. So D of I is nothing but what? A list, right? D of I will be this list. Either this list, this one of these lists will be D of I, another will be D of J, depending on what is I and what is J, right? I is 0, then D of I will be this list. Let's say J is 5, then D of J will be this particular list. So those are our D of I and D of J. So as it's a list, as we all know, in order to access a specific element of a list, we can use these special functions, right? First and last. So we are comparing first of X with first of Y. So that's D of I becomes X, that is our first list, and D of J becomes Y, which is our second list. So we are comparing first of X and first of Y. That means what is first? First is what? Date of birth, right? So we are comparing date of birth of 2 students. And if it is equal, then we are doing and last X is equal to a last of Y.
Gender.
That means this is gender. So if 2 students date of birth as well as gender, if both entities are equal, then we are returning true, or else we are returning false, right? So what this, so in order to summarize this, what is related procedure is returning?
Sir, if there is at least one pair of students who have
Same date of birth and same gender.
Same gender.
Yeah. So it returns true only when students have same date of birth and gender, right?
Yes. Sir.
Otherwise, if
at least one student.
Both has to be true. And if one of them is not equal, then we are returning false. Yes. Right? That's what this procedure is doing. And if it returns true, then we are doing this A of ij is equal to 1. And that is the place where the original matrix is getting updated. That means now we can say I and j are related. And in order to mark them related, we are making the value in that matrix as 1. For I row, j column, it will become 1. Right? So far, is it clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir. But
yeah.
We can also go through J and I, like A, then J, then I, in the column, then row. It is possible, no?
Yeah, it is possible, but it's better to follow one of those methods, right? It will be easier. So if you want to consider it that way, it is absolutely fine. There's nothing wrong in doing that. See, ultimately what you should, as we call it, traversal, right? As you have to go through entire matrix, cell by cell. Either you go row by row, column by column, doesn't matter, right?
Right.
Unless and until you cover the entire matrix, it's fine. But it's a, I will not say it's a standard, it's a convention to read row first and then column. So usually we do A of RC, right? Even in mathematics, you know that both ways are allowed. But usually it's a standard practice to, stick to first row and keep changing the column. Once we exhaust them, we'll move, change the row. So that's how it is, right?
Okay. But
Yeah.
So this is a symmetric matrix, right?
Yeah, exactly. So it's a graph, right?
Yes.
So in graph, you will always get a square matrix, right?
So square, yes, but aij is equal to
Yeah. In
AI.
this case, for this particular example, it will be a symmetric matrix, because when I say I is related to J, that means J is also related to I. But we don't have to write that directly over here, right? Later on, the value of I and J will change, and we'll get those values eventually, right? Because I is running from 0 to 5 and J is also running from 0 to 5. So
Yes.
yeah, so if 0, 5 are related, then later on I becomes 5 and J becomes 0. That time 5, 0 will also become 1, right? So that's how it will happen. And that's the advantage of having nested iterations, right?
So can we call this a undirected graph?
Yes, it is undirected graph. So whenever, as you said, right, if two are related, right, there is no direct relation as seen that A is related to B. That naturally means B is related to A. So in that case, it's a undirected graph.
and when it is undirected, it is logically, we can say that it's symmetric, right?
Yes, correct. So undirected graph and symmetric are same things.
So arrows are pointing in both directions, right, sir? So when
No,
arrows
in that case, usually, in that case, we do not actually draw arrows.
No,
We will just draw a line from one node to other node. No arrows. Arrows are not required in that case.
Right.
Okay. Yeah, we will come to that. We have the graphs also. So this is how the entire table will update one after the other. This is something, if you want, we can go through it, but it's a very trivial thing. So we have I as 0, 0, 0, 0. Nothing will happen because I and J are equal. There is nothing is important over there. Then we'll change the J. I remains 0. Then for 0, 1, these are the values, right? D of I is this, D of J is this. 7 November male, 7 November male. So they are related. It will return true. And the index value in the matrix will become, for that row, it will become 1. Right. So the above one is the actual data and the below table represents the matrix. Right now the whole matrix is not there, just the first row is there, whatever we are iterating as of now. So we'll keep doing this. Next, the same thing what I said, the cell will get updated, and ultimately our matrix should have these. These are the similarities, right? At 0, 1 we'll get it true. At 1, 0, of course, at 0, 1 is true, definitely 1, 0 is true. Then 5, 4 is true, that means there will be somewhere there is 4, 5 that will also be true, and so on, right?
So, but there will be a case of 0, 0, 1, 1
Yeah.
also, no?
Yes,
So
correct.
in that case, so but here it is written, this is related, it's not called as I equals to J, like in the second row, 0, 0 in the table you are showing. So why it is saying like that?
Because of this condition, what it says, if I is not equal to J, can you see this particular line
Yes,
over
sir,
here?
yes, sir, yes, sir.
Yes,
Then we will not be even calling this procedure, right?
Right.
Okay.
Because 0 will be equal to 0.
See, 0 is not equal to 0.
False.
If they are not equal, then only we are calling this inner if, right?
So then in matrix, what will be the value of 0, 0?
It will remain as it is, which is 0. Initially, if you remember this create matrix function, which is explained in the lecture, right?
Okay, yes, sir, understood.
Yeah, so initially you have to assume that all the values in the matrix are 0. So it will stay as it is.
Sir, all diagonal elements will be zeros, no, sir?
Yes, correct. All principal diagonal
elements, yeah.
Yeah, principal diagonal elements will be 0.
Yes.
At least in this case, right?
Yes, sir.
Yeah. Okay. So yeah, this is not the entire matrix, but some random lines of that matrix. Entire matrix, it's not possible to draw. Yeah, this is the entire matrix. This is how the entire matrix will look like, right? 0, 1 is 1. So 1, 0 is 1. Then it's symmetric. So these are diagonal elements are symmetric ones which are related, right? So this is our full matrix. This is something, I mean, later on, we will put these slides on the portal, right? So that point, it will help you if you want to, go through it again for practice or something. And ultimately, this is how our graph will look like. Now you might see that one node is missing here, but that's an isolated node, right? Which is not actually a part of this graph. What we are interested is cliques, right? Because our entire question was based on cliques. How many cliques? What is the relation among nodes between cliques and so on? So single node doesn't form a clique. So that's why that isolated node is not there, which is this node 2. Because 4th Jan, only one student has this date of birth. We have these two male students who shared date of birth, which is 7th November, 0 and 1. So that forms our one clique, which is of this male student. And then there is another clique of this blue color over here, which is of female students, which are having this date of birth, May 5th, right?
Excuse me, sir.
Yeah.
Sir, this 3, 4, 5 forms a clique. Will it mean these are the students who have got the same date of birth and of same gender?
Correct.
That means it follows the given condition.
Yes, correct.
Can we understand like that, sir?
Yes, see, they form, okay, the word clique will come to that later. As per the our given pseudocode, right? If two students are related, we are supposed to put a age between them. As in when we said that this thing,
Yes,
see,
sir.
when we say A of ij is equal to 1, that means what?
There
we
is
are
an
putting
age.
a age between I and j, right?
Yes,
That's
sir.
what
There is an age.
Yes, there is an age. So
Yes,
there is an age between 3 and 5. Why? Because 3 and 5 share same age and their
same
gender
gender.
is same.
Yes, sir.
Right. So that's
and,
why.
Sir,
I got it.
between
Thank
two
you.
nodes, there could be a clique, right?
Yeah. So see, 0 and 1 are two nodes, right?
So two nodes can form a
Yes.
clique. That's what.
So what is the definition of clique?
So if an age is going in both ways, like in between two nodes.
No.
Similar.
What is the meaning of clique?
So every node is connected to every other node.
Sorry,
Each node is
Correct. What is
each
the
node.
meaning of clique? Every node has to be connected with
to
every
every
other
other
node with an direct edge. Okay. The important part is with an direct edge.
Okay.
Then only the particular that graph or that subgraph, sometimes the entire graph or sometimes the subgraph is referred as clique. Right. So as you can see, there are only two nodes. And they have edge. That means they both are connected with each other with direct edge. That satisfies our definition of clique, right?
So sorry to interrupt you, sir. Can you please again repeat clique, sir?
Yeah. So definition of clique is a node has to be connected with every other node with an direct edge. Okay. If we form such nodes, such vertices of a graph, then that subgraph or the entire graph, depending on whether it covers the entire graph or some part of graph, that particular structure is referred as clique. So as you can see, there are 3 vertices here, and they all are connected with direct edges. 3 is connected to 4, 3 is connected to 5, 4 is connected to 3 and 5, and 5 is connected to 3 and 4. So all are connected with each other with direct edge. That means they form a clique.
In this 3, 4, 5 clique, sir, can't we say that 3, 4 is also forming a clique?
Yes, correct. So 3, 4 also forms a clique. But usually when we say clique, right, we try to get maximum number of vertices in it. So if we can find a bigger one, then we ignore the smaller ones.
So it is undirected, no? Because we are going both ways.
Cliques. The concept of cliques, you have to relate it only with undirected graph. Do not combine these two things together. When you talk about clique, you are talking about undirected graph. Okay. Yeah. Okay. I mean, yeah, there is a concept of cliques in directed graph and all that, but that's something which is not part of computational thinking. So in computational thinking course, when we talk about clique, you have to assume we are talking about undirected graph. Okay. Because that's something which is simple and easy, and that actually has some applications. A directed graph with cliques is something complicated and doesn't have much of applications. I mean, applications of cliques is something you will see in upcoming weeks and even upcoming courses also. So when we talk about click, just assume we are talking about undirected graph. All right.
Sir, in this 3 nodes click, we should
Yeah.
consider it as one click, is it?
Yes, correct.
And,
a click of size 3. That's how we should
okay.
refer it.
Then in that click itself, can we consider that 2 nodes click like 3, 4, 4, 5, and 3, 5?
Yes, there are these sub clicks are there, right? But
yes,
we always ignore them. See, the word click comes into picture as a collection of nodes, maximum number of collection of nodes which are connected to each other with direct edge.
Okay.
Right. So if we can form a click of size 3, then we should ignore all those clicks of this sub clicks of size 2.
Why are you saying direct edge, sir? Because it's it's connected in both ways.
Okay, I'll tell you why direct edge. Let's assume this 3, 4 edge is not there. Okay.
Okay.
Then there is a way to go from 3 to 5, 3 to 4 via 5.
Yes. Okay.
That is not a click.
But
that's why I said direct edge. That direct edge part is important. Okay. Yeah. Okay. So is this part clear? These are the 2 clicks which we have.
Hello.
Yes. Jishan. Yeah.
Sir, if there is a single node present within the graph which is connected to anyone, then there is the single node is a click, or maybe considered another thing.
No, it is considered as isolated node. A single node doesn't form a click.
Okay.
Sir, in this case also, if in this 3, 4, 5 nodes, if all the nodes have two edges, like one for incoming edge and one for outgoing, then will it form a click? In the
that's what I was saying, right? So when you say incoming and outgoing, that means you're talking about directed graph, right? So incoming as well as, say, when you have incoming as well as outgoing edge, that means it's a symmetric graph, right?
Yes,
there is no point having 2 edges, one is going and one is coming, which is exactly equivalent to what you have right now. It's undirected graph with edge between vertices, right? It's same thing. Okay. Got the point, right? What I'm saying?
Yes, sir.
Yes, sir.
Yeah. Okay. So let's move. So this is what our graph will look like in a pictorial form. So now we can go back to the question and see what's the correct answer. So as most of you answered it correctly, option 2 is in every click there is at least a pair. That's not possible, right? Because as per our condition, we are calling 2 students or 2 nodes related only if their date of birth is same. So and of course the gender is same. So keeping that in mind, option 2 is not a valid statement, right? So is there any doubt with question 1?
No, sir.
Okay, then shall we move to question 2?
Yes.
Okay, so let's move to second question. Okay, so read this information, and this is a common data for next 2-3 questions. So problem 2 and 3, and I think 4 also has some reference to this, but that's something we'll come to that later. So first read this. I will give you a minute to go through it.
Sir,
Yes. Yeah.
sir, star is a number of star or the rating of the star, sir.
In what sense you are saying? Okay, the star one, star two,
When
right?
you bring the index of stars, it is written, sir.
Okay. No, there is no rating or anything. Rating part is not there at all. See, every star has allotted a number. So every star has allotted unique number, like a roll number or something, right? So that's the number we are talking about.
Okay, sir, got it, sir.
Yes, sir. Read the question.
Okay. Others, if you are ready, shall we move to? Can we move?
Sir, sir, I have doubt.
Yes.
Shonindu.
Yeah.
Yeah, sir. What does it mean by star 1 is 3 and star 2 is 1?
Okay. Where is it written? Star 3 is okay.
Star
Okay. The
1
first
is-
row, right?
Yeah, first row.
Okay. So what does that mean is there is a movie which is which we will refer as movie 0, and in
Okay.
that movie 0, there are 2 stars in every movie, right?
Okay.
So the first star of that movie is star number 3, actor number 3.
Okay, actor number 3.
Actor number 3 is star 1 for movie number 0.
Okay.
And actor number 1 is star 2 in movie number 0.
So each and every movie has 2 stars, star 1 and
stars.
star 2.
Correct.
Okay.
And
As we say, right, each row, if you read the second sentence, each row in the table corresponds to a movie and has exactly 2 lead actors.
Okay.
So star 1 is always the protagonist and star 2 is the elder.
Yes, that's what I
Not required. That information is not required. Don't worry.
Sir,
You can
here
assume either way, but that's not relevant for our code.
It is
Who's
the
protagonist and who's
assumption.
antagonist, that's not required. It's just part of the story. Okay.
Yes.
So okay, got it.
Okay,
Sir,
sir.
here
Thank
each and every actors are being assigned to the movies. Is it? I mean, if there is total n actors, then totally n actors are being assigned.
Yes. All actors.
No one
I
is
mean,
left.
whatever actors we have in dataset, they all are they all have
okay.
acted in at least in one movie.
Okay. No one is left. Okay.
No one is left.
Okay. Let's move to
Okay.
the next.
So is it clear with the background, the context of the problem?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Then we'll move to the pseudocode part of it. So this is the left side pseudocode is the first one you are supposed to execute, followed by the pseudocode on the right hand side. So go through the pseudocode, try to understand what is happening, then we'll move to the question. In case if there is a question related to the doubt related to the question, please let me know. I will not explain you the pseudocode, but if there is other and some clarification you require, let me know.
Done, sir.
Sir, excuse me, sir.
Yes.
Will you please explain this line, sir? Co-stars star 1, star 2 is equal to that plus 1.
Correct. So, see, co-star is what? It's a matrix.
It's a
right?
matrix. Matrix.
So matrix will have some value already present in it. As we know, create matrix gives
Yes,
us a
sir.
matrix with all zeros in it.
Yes, sir.
So we are just adding +1. We are doing +1 into that value.
Just adding the 1.
Correct.
Okay, sir.
See what co-star star 1, star 2 will give you. What is star 1 and star 2? Some numbers, right?
Numbers.
So that is nothing but some index of the matrix, right?
Yes, sir.
So it will have some existing value. We are
That one has to be added to that.
Correct. It just like A is equal to A plus 1.
Yes, sir. Got it.
Yeah.
So this is also undirected graph, right?
Yes, correct. This is also undirected graph. In week 9, most of the questions we have undirected graph. I think even in lectures, if you observe, there are very less examples of directed. I don't remember exactly, but I don't think there are any place where they have used directed graph. There might be some odd occurrences, but directed graphs are slightly more trickier. So we'll go into that even more detail in later weeks. But yeah, some odd examples are there, but more focus is on undirected graph in this week. By the way, we have 3 weeks of graph, so it's of that importance. I mean, list and dictionary, we spent only 2 weeks per concept, but for graph, we have 3 weeks, week 9, 10, and 11. And in week 11, we are introducing some extra thing beyond graph, but yeah, the main concept for these all 3 weeks is graphs.
Sir?
Yeah. Yes,
sir, shouldn't sir co-star ij is greater than equals to max, sir?
Not necessary, right? It's greater than max is also fine, right? What's the problem in having that?
I mean, if that co-star will be like 3, okay, greater than max. For example, max will be 3, okay. So if co-star will be, equal to 3, so it can't be like matched with each other, right? So that is the reason.
Yeah. So what will happen? The value of ij will, the stars is equal to ij, right? Only it will affect this stars variable, right? Having less than or greater than equal to will have impact only on this variable stars.
Yes, sir.
Correct.
It will
if it is greater than it will be the first occurrence. If it is greater than it will be the first occurrence. If it is equal to, it will be the last occurrence.
Last occurrence, correct.
Yes, sir.
The max value will not change, right? Irrespective of whether you have greater than or greater than equal to.
Correct. It will be either ij or ji at the end.
Yeah, correct. So ij, if there are such multiple such co-stars are there, so whoever we find first, that list will be assigned to the stars variable. And if we make it greater than equal to, then last such occurrence will be allotted to this variable. But other than that, the meaning of variable stars will not change, right? Actual values might change, but we are not interested in actual values over here.
Excuse me, sir.
Yes, Soumyadeep.
Yeah, sir. Sir, I had a minor problem in practice assignment. And should I ask that now or later?
No, this session is not for those kind of problems. This is solve with us.
Okay.
So if we have time at the end, I don't mind answering, but I don't think we will get enough time towards the end. But if we do, I will help you out, or else you can post it on the forum.
Okay, then I'll do that only.
Yeah. Okay. The open sessions for this week already happened. We had 2 sessions earlier in the week.
I was a little bit ahead, a little late, so I couldn't finish that up. That's
okay. Yeah, I understand. Usually a week after quizzes, right? That's usually hectic one. Yeah, we understand that. So
yes,
as I said, right, if we get time, I will help you out towards the end of the session, or else post it on the forum. All right. Yeah. So is everybody is okay and comfortable with this pseudocode?
Yes, sir.
Okay. Then let's move to next slide. Okay. So this is the right hand side of the pseudocode. This is same pseudocode. Don't worry. You don't have to go through it again. It's the same pseudocode which was there on the right hand side and along with the question. So it's an open-ended question. You're supposed to type it out. So you can say max colon your explanation, stars colon your explanation. You can type whatever you feel is correct. Okay, let me see what all are submitting. Okay.
The slide, sir. So question, sir.
Question is there. You can see that on your peer deck. Whenever there is a question, you are supposed to look at your peer deck. Otherwise, you will not be able to submit the answer. Okay. We don't want actual values. Somebody wrote some random value for some reason. We want to know what those variables represent.
Can you share the question?
Yeah, okay.
Because while typing answer, I'm not able
sure,
to see the
sure.
question.
I understood. Hold on. Yeah.
Okay. Okay.
See, this is not like the question from previous. I mean, it's not like previous question. Okay, this is not specific to that table which we showed. The table was just a mere representation of actual data set. We are not asking about what is the value of max and what is value of stars. We are asking what it represents. So you have to give a statement. Variable max will represent so and so. Stars variable will represent so and so. So that kind of statement we are looking for. Because there are some one or two students who gave some numbers. I don't know from where they got those, but yeah. So this is a clarification for those students. Okay, so some 27 students have submitted so far. Whether guys, do you get to see that how many have submitted and anything of that sort?
Yes, yes, sir.
You also see that, okay, right. But you can't see others' responses, right?
Yes,
Yes, sir.
Yes. Yes, who's that?
Sir, we can't see others' responses.
Yeah, I mean, ideally you're not supposed to. I just asking that how it looks on the student side.
Done, sir.
Okay. Everybody done?
Yes, sir.
30
Yes, sir.
responses are there. Others,
Yes,
if
sir.
you need some time, let me know, or else we move. Okay, I think everybody is done. Whoever is able to answer. Let's see, just quickly scroll to the responses. We'll not go into detail, and then maybe we'll, okay, max, somebody is saying, in the background, the actual details are stored, that all those details. But anyway, yeah, maximum number of collaborators by co-stars, a list of stars collaborated the most. Maximum number of movies in which pair of stars acted together. Yes, okay. Occurrence of pair of actors who acted in max movies. Okay. Okay. I mean, wordings might be different, but almost all looks to be on the same page. Okay, yeah, this is what I was talking about. I don't know from where you got this, but yeah, okay. All right, fine. Then let's start with the solution, and then we'll see most of you have got it right, but yeah. So we can go through it quickly. So solution, the first part of the pseudocode, right? What we are doing is, I think somebody already asked, so I explained this, but we are taking first of movies of I, right? So that will give us that particular star entity from there, that is star 1, star 2, which are nothing but some numbers allotted to those actors. And we are simply incrementing it, when they have worked together more than once. So let's say star 1 and star 2 have acted together in a movie 4 times. So they have worked as co-stars in 4 different movies. So at the end of this entire loop, right, or entire pseudocode, at the end of execution, the co-stars star 1, star 2 should have that number 4 over there, right? That's how it will be. Number of movies they have worked together. That's the ultimate number which will come in the matrix. So yeah, let's take that with some couple of examples. We'll go through it quickly. So let's assume star 1, star 2, 3, and 1, and they have acted together, right? In this movie 0. So that means row 1, column 3, they have acted with 1 time. That definitely, that means 3 and 1 should also become 1. As someone rightly pointed out earlier, it will be a symmetric matrix, right? So maybe another example. Now 1, 2. So
So
because
why
of
we
1,
are
2,
taking 4 by 4 matrix? Can't we take 3 by 3 matrix?
yeah, we can take, as I said, right? Just an example.
No,
See,
sir, but
we
then
don't know how many are there, right? We don't know how many
no.
are there.
So you are taking 4 by 4 matrix, then you can put 3 into the matrix. But let's suppose there are only 3 by 3 matrix. So then how will you do?
So that's what. So it's not like you have to take some matrix of specific size. You have to take a matrix of size n into n. That's why we write this line, right? Whatever number of, okay. So co-stars is equal to create matrix n comma n, right? So from where this n is coming? N is number of movies, right? No, not
No,
number of
sir.
movies, number of
Number.
actors,
Yes.
right? N represents number of actors. So if we have 3 actors, 300 actors, 3000 actors, or whatever number of actors you got, you create a matrix of that size.
Okay,
Right?
suppose we take, there are 3 actors. So then n equal to 3.
Yes, n is equal to 3. Then you should have a matrix of size 3 by 3.
Then what will be the value of star 1? Let's say, take the initial example. Then star 1 will be 3 and star 2 will be 1.
Correct.
And
Sir,
now how
star
will
1 can't be 3 here because the index number should be 0, 1, and 2. If we are
that's
taking
what I'm
a
saying.
number of
That's
3.
what I'm saying. Now how will you put 3? Because column will be 0, 1, and 2 only. Then how will you construct the matrix?
Okay.
Stars are numbered from 0 to n minus 1.
Yes, correct. But how many total stars are there?
Only 3.
Only 3 stars are there, right?
Yeah.
Then you cannot have number 3, right? Then how you number 3 will come?
So that's what I'm asking, sir.
See, if you have star number 3 in your data, that means there has to be at least 4 stars, right?
Okay.
Because stars are numbered from 0 to n minus 1. So if you have a star whose name is number 3, that means you have at least 4 stars, right? 0, 1, 2, 3. There has to be 4 stars.
Okay.
You're getting that my point, right?
Yeah.
Yeah. So then that means your matrix will be of size 4 by 4.
Yeah.
That's the point. Number of okay, I'll just maybe I'm breaking the flow, but let me go back. How this is created? Okay, how this is created? From where that n is coming from? Do you remember? There is a pool of n actors, right? And those n are named from 0 to n minus 1. So your n minus 1, as if somebody is named as 3, that means your n becomes 4, right?
Yeah.
At least 4. We might have few more after that, but it becomes at least 4. That means your matrix becomes 4 by 4.
Yeah.
Right?
Okay.
Okay. So
I thought that is a serial number.
No, that's why I'm saying this is the actor number. Actors are named differently, and matrix will have numbers from 0 to n minus 1, right?
Yeah.
Yeah. Okay. So after this 3, 1 example, we were talking about another example 1, 2, and because of that 1, 2, and 2, 1 both will become 1, 1, right? Let's take one example and then we'll move to back to pseudocode. Now you tell me what will be the value for this. Okay, so right now we had this. Instead of *1, *2, let's say we added one more, right? So for this thing, movies 2, there is another list called 1, 2. Remember this. Earlier movies 1, actor 1 and 2 acted together. Now another movie is there named movie 2, and for that those actors 1 and 2 acted together, right? And because of that, these values which were earlier they were 1, 1, now they will become 2, 2, right? Because of that +1. Is that clear? That's how the entire matrix will get updated.
Yes.
Right? Okay. So I mean, this is not the final. I mean, this is with some example. Okay, as this is some example we have taken with 4 by 4 matrix, and with some value, this is how the graph will look like, right? So that means this actor number 0 and 1, they have worked together in 4 different movies. That's what these number which is returned on the edge refers to. Number of movies these 2 actors have worked together. Actor 2 and 0 and 2 have worked together only once in some movie, one alone movie, right? So that's how our entire graph or a matrix will look like with some sample data. Okay, and then we are supposed to execute that second part of the pseudocode when we have declared that max integer variable and stars as an empty list, right? And then we are iterating over the entire matrix, and whenever we find the situation where some value which is greater than max, we are updating max and stars. So ultimately, as even the variable name suggests, we are finding maximum co-stars. So that's what we are finding, who has maximum co-stars, right? That's what we are looking for, right? So let's go to that. Let's build up to the final answer. I mean, you already have most of your answered it correctly, but yeah. So this is how it will come, right? The co-stars, the value 4, which is for 0, 1. And because of that, the max will get updated and star list will get updated. I mean, that's 0, 0 will ignore 0, 1. The first ever we got is 4. So 4 and 0, 1 is the updated value as per this example. And we will keep doing that. We'll do that whenever co-stars of ij is greater than max. And coincidentally, in this case, the 4 is the highest value we have over here. So because of that, it will never update, and ultimately 4 will be the value for max, and stars will hold that 0, 1 as a pair, right? So that means maximum number of movies in which any pair of stars have acted together. As I said, you might have different wording unless and I mean, if your meaning is same, your answer is valid one. Okay, and then stars represent that particular pair. I mean, the pair of actors who have worked in maximum number of movies together.
So,
all right. Yes.
Actually, it will return the index number of pair of actors in any order.
Yes, correct. So see, a list will either be 0, 1 or 1, 0. It's still same, right?
And sir, one more thing. So like
when we say pair of stars, then that when we say pair of stars, it actually doesn't make much of a difference in a sense that who comes first, right?
Yes, sir.
Right.
Yes,
when we
sir,
say actor X and Y work
that,
together, then X and Y and X, they work together. That's more important, right?
Okay.
Sir,
I was
some,
also
like
saying
if,
that it will return the index number of that stars. I mean, more specifically, if you say it will
Correct.
return the index numbers, not the names or like that.
But we never said name, right? Or is there any way we can say name? A pair of
No.
stars who have acted together in the mag. Yeah, I mean, as I said, right? It's unless until the message is clear and you understood what's happening, it's fine.
Yes,
right?
sir. Okay.
Yeah, I
sir,
mean,
one
yeah,
more
more
thing, sir.
clarity you can say index number, but yeah, correct. Yes, Abhinandan, yes.
So my question
Sir,
is like, sir, two or more pairs of stars have done a maximum number of movies together.
Correct.
So when the first occurrence will come, so we have to mention that first occurrence also, na sir.
Yeah, I mean, yeah, you can mention that.
Okay.
sir, I
Yeah,
have
I
a
mean,
doubt.
yeah, Vaishu, just hold on for
Sir?
a second. Yes, as you said that point, I think somebody returned that precisely in the response.
Yes,
I
I
think
wrote,
it
sir.
was it you. Yeah, okay. Yeah, I mean that's even more precise one, assuming that there is a possibility of multiple such maximum maximum numbers, right? Yeah, but this is more towards graph. But yeah, fine. Your answer is also
Okay.
correct. It's
Yes,
more
sir. Okay.
accurate.
Yes. And sir, a pair of stars and a list of stars are both same now.
Yes, see what is pair? Pair is a list of size length 2, right?
2. Yes, sir.
Yeah, so that's what a pair is.
Yes, sir. Got
Okay,
it, sir.
yeah.
Thank you.
Yeah, thanks. Yes, somebody, Vaishu or somebody was talking in between. I mean, that's the name.
Yes, sir. It's me, sir. I have a doubt. As he mentioned, if a person if two pairs of actors, but the iterator will note only the first pair what it sees.
Correct. Exactly. Correct.
Okay, I have some uncertainty while typing this, so.
No. You're whatever you just said, right? It's absolutely correct. The first occurrence of such maximum, that pair will be recorded under that stars variable.
Okay, sir. Thanks.
Yes.
So in this matrix, what more information we get from the lower part of the matrix? Lower part of the matrix we can derive from the upper part of the matrix, right?
Yes, correct.
So what more information we get from this lower part?
Okay, so see, whenever we have symmetric matrix, right? I mean, ideally you can have only the upper triangular matrix, and that actually serves the purpose.
Yes, sir.
But for the for the complicity's sake, or just to make it a complete matrix, we add the values. I mean, this is not just in computational thinking or this example. In general, whenever there is a symmetric matrix, it actually doesn't make much of a sense to have same value for 2, 3, and 3, 2 twice stored. It's actually we are wasting some memory over there, right?
Memory also and time also, because we are.
Yeah, absolutely. You're correct. So there is alternative to this. I mean, professor have talked about it briefly in some upcoming weeks, but we'll study that approach of storing graphs in computers maybe in our later courses. We have a course called PDSA, which is again taken by Madhavan sir, by Professor Madhavan Mukund, and that's the place where we will move away from matrices for graphs, and we will start some different approach, which is much more optimized version of a matrix. Okay,
Sir,
so
I'm
for
still.
now, let's stick to this. As you pointed out, yes, it is time consuming. It is a wastage of time and memory when it's a symmetric matrix. If it's not, then definitely we should have the entire structure. But yeah,
Symmetric matrix you will get only in undirected graph.
yes, correct. Yeah.
Sir, the
Sir,
code
I'm
stars.
still not able to understand this matrix.
Okay, Dave, yes. I will explain you that. Okay, yes,
No, sir,
Rahul,
no,
you
sir.
were saying something.
No, sir. I'm asking another doubt.
Yes, sir.
Dave has.
Okay, I think I missed understood who's saying what. Okay, Dave, is your part clear? I'm supposed to explain the matrix to you, right?
No, sir. I'm not asking about matrix. Sir, I'm saying that the code of co-star 1 and co-star 2 equals to co-star 1 star 2 plus 1, and beneath that co-star 2 star 1 co-star 1 co-star 2 co-star 1 plus 1. These two are different operations, na?
This one you are saying, right?
No, sir. Yes, sir.
Yes,
These
this
two are
highlighted
different.
code, the yellow highlighted code, right? Yes, these two are different operations, correct.
The star 1, star 2 is different, and star 2, star 1 is different. Because
Correct.
in star 1, the star 1 is the protagonist, and star 2 is the antagonist, and star 2.
No.
Yeah, you can assume like that. There is no harm in doing that. Okay.
Oh, that's what I'm asking, sir.
Yeah, correct. See, these are two different statements. Why? See, whenever we say actor 1 and actor 2, as we saw in this example. Okay, in this example, if you see what it says,
sir.
actor 3 and 1, they have worked together.
Yes, sir.
That means we should make 1, 3. We should increment this as well as this one, right?
Okay.
So star 1, star 2 plus 1. It will make star 1 is 3, star 2 is 1. So 3, 1. So what is 3, 1? This is 3, 1. So the first line of that pseudocode will make this one as 1.
Sir, but when we say 3, 1, so it is automatic implied that 1, 3 would be.
Yes, that is correct. But the matrix should also reflect that, right? At human level, we understand that, but how computer will understand it unless and until you make that change in the matrix. Right. See, if you do not make that change, then it will not be a symmetric matrix. Then it will not be a undirected graph. Then computer will treat it as directed graph.
Yes, diagonal with non-matrix.
Right.
Yeah.
So in order to, that's the only way computer will know. At human level, we might understand this, but there is only way. I mean, the matrix is the only way computer will know what kind of graph we are looking at.
Or we can say costar star 2 star 1 is equal to costar star 1 star 2.
Yes, correct. That again we can do. I mean, instead of this plus 1, you can this left hand side of first statement, you can put it as the right hand side of second statement. Yes, that's
it is same thing like IJ and JI. Like
yes, correct. I mean, see, unless if you are updating the value is important. Okay, the how you update it, that's up to you. It's every programmer has his or her own way of writing codes, right? Unless and until it is doing what is expected, it's fine.
Got the point, sir. Thank you.
Yeah. Okay.
Sure.
Yes.
Thank you, sir.
So why is it updating 1, 1 or 2, 2? I didn't understand that. Like only one value is getting updated in the specific
Sale, correct. But what if, let's say, these actors 3 and 1 work again in another movie?
Okay.
Then it should become plus 1, right? As per these statements.
Yeah.
Then it will become 2, 2, right?
So the 1, 1 is the first time they act in one movie.
Correct. So
and
for
the second
example,
time it gets added to 2, 2.
Yes, it gets added. For example, like these two actors, right? Movie name 1. There is some movie name 1 movie. And in that movie, actor 1 and actor 2 work together. Because of that, these two green colored highlighted cells become 1, 1. Correct?
Yeah.
Then there is another movie called movie 2. And in that movie, again, those same actors have worked together.
Okay.
And because of that, now it should become 2, 2, right? Because they work together twice in two different movies, movie 1 and movie 2.
Yeah, got it.
That's why it became 2, 2. Let's for example assume that they work again in some other movie. Let's say movie number 20.
Okay.
Then it should become 3, 3, right?
Yeah.
By row we are presenting movie number. Is it?
Yeah, this I represents movie number.
Okay, that's where I confused everything.
Yeah, that's what there, right? I mean, movies of I. It was that's the place from where you're getting this first and last, right? That's the another dictionary we have.
Okay, got it.
Okay, sir, got it.
Okay. Yeah.
Thank you.
Okay, sure. So, any other doubts?
No, sir. Please move to the next.
Okay, then we'll move to next. So, I mean, this is something I'll go quickly. This is the line where we are checking the condition whether it's max or not. This is a very detailed explanation of step-by-step procedure. We'll skip this. Yes, somebody was saying something. All right.
Sir, can you open the matrix, the last matrix?
Okay. Yeah, this is the same. Yeah.
So just can you explain me what is this rows and column are showing us, or what they are telling us? What are they?
Okay. Okay. So Rahul,
Is
right?
it? Yeah.
Yeah. Okay. So Rahul, what this entire matrix is representing is there is a actor, named 0 number actor. The name of actor is 0, or some assigned number to actor is 0, and there is another actor named 1. So actor 0 and actor 1 have worked together in 4 different movies. That's what this particular matrix is. You take some number from the row side, take some number from the column side, and you map them. So whatever their common cell is, that common cell represents how many times these two actors have worked together. For example, actor number 2, that means this entire row, and let's say actor number 3, this last column, it is 3. What does that mean? Actor 2 and actor 3 have worked together 3 times in 3 different movies.
But sir, these 0, 1, 2, 3, these are the dictionary keys, right?
See,
0,
this
1, 2, 3.
left hand side,
These
the
are dictionary
first,
keys.
this row number and column number are dictionary keys, but these values are these are values in the dictionary. These are keys. These are keys.
I'm asking the.
Yeah, this 0, 4,
I'm
1,
asking
0,
about the rows
4,
and
0,
columns.
2, 0. These are values in the dictionary.
Yeah, these are values in dictionary, but I'm asking that row ind ex equal to 0. That is the key of dictionary, right?
Correct. That is key of dictionary. Correct.
And but according to question, key of dictionary represent the movie numbers, not the actor.
That is for the other dictionary. There are 2 dictionaries. There is 2 dictionary, movies and co-star. See, co-star is that matrix, correct?
Yeah.
And movies is a dictionary.
Yeah.
So there are 2 dictionaries. Movies is just a dictionary and co-star is a dictionary of dictionaries, which represents the matrix. So there are 2 actual dictionaries. See, movies is this particular dictionary. Movies of 0 represents 3, 1. That means actor number 3 and 1 have worked together in movie number 0. This is that movies dictionary. And using that, we are creating this another dictionary called that particular graph or that particular matrix. So that second dictionary, which is actually a dictionary of dictionaries, which is nothing but that matrix, we are constructing that using this original given dictionary, which is called movies. Okay.
Okay, sir.
So one dictionary is given to you, and second dictionary you are supposed to compute using this particular pseudocode. This entire the combination of these 2 pseudocodes. Okay.
Okay, sir. Okay.
Yeah. Okay. Then now we'll move to problem 3. Rahul, anyway, we will be uploading these slides on the portal, so you can go through them once again and practice them again.
Yeah, even practice assignments, sir, I was unable to construct the matrices.
Yeah, I understand. I understand.
So
That's
just
why
one
I'm saying.
question. Instead of that pair we have, suppose we say that the first actor is the protagonist and the second actor is the antagonist. Then the graph would not be an undirected graph, right?
Okay. Then every time we have to specifically mention, right? That means you are adding additional information into it. You are just you cannot just say they have acted together or they are co-actors. Then you are adding additional information on top of that, that who acted in what capacity, right?
Yes, yes.
So then only direction is not sufficient.
So ij will not be equal to ji.
Yes, then that additional information, we should have some mechanism to store that information as well.
Yes, yes.
So we have to consider the protagonist and antagonist also, like.
Yes, correct. Then your graph may not mean whatever graph we have studied so far may not be a sufficient entity, right?
So,
I mean, it may not be a sufficient data structure. You will require some additional information on top of that. who has worked in what capacity. That information you cannot store just using this particular matrix, what you just saw.
Okay.
Right?
So is there any way? So
Yeah. I mean, you can add one more level of nesting into it, right? I mean, you can, for every pair, instead of pair, you can pair as in what currently you have list. Instead of list, you can make it a dictionary, and you will have two keys in that dictionary, protagonist and antagonist. Those will be your standard keys for every movie. Instead of list, you will have a dictionary, and in that dictionary, you will have these two values. Or you can inherently assume that the first of that list is protagonist and second is antagonist or something of that sort. You have to inherently assume that. Either you assume that or convert it into a dictionary.
So the rows will represent the protagonist and the columns will represent the antagonist.
Right.
And every pair of rows and column will represent one protagonist and one antagonist.
Right.
So row ij will not be equal to aij will not be equal to aj.
Correct.
Yes, because
in fact, it will never be equal, right? In that case, unless and until they change the roles and work in different movies.
They may be equal because if in one movie one actor has acted as protagonist and other as antagonist, in another movie the second one is acted as protagonist, and the first one is acted as
then it will become 1-1. Correct.
Yes. So it may be equal, it may not be equal.
Correct. But then the problem is your graph will not have this information, right? It is something outside graph. I mean, it is something at your understanding level. You are saying this, right?
Yes.
We are not able to store that.
Yeah, you will not have any way to represent or to store this information as part of the graph. When there is an age, I mean, you can then you'll have to convert it into a directed graph, obviously, because it will not be a symmetric graph. So directed graph is there, but as I said, right, you will require that information, that which movie and all that information will be required. Just the number alone will not suffice this particular problem. Because see, as you said, right, the later on some point it become 1-1, right?
Yes.
That information is there, that 1-1 is there. Yeah.
If the role is constant, like if the role is constant, they are never going to the same. Like one actor is doing the same role in every movie. And if it is changing, is like he's actor as a protagonist in one and another in antagonist in that. So then it will be applied that they are not equal.
So aij will be incremented if I is a protagonist and j is an antagonist in any movie. aij will be incremented if I is the protagonist and j is the antagonist in any movie. Then aij will be incremented, but aji will not be incremented.
Correct. So it will not be ultimately it will not be a symmetric graph. It will be a directional graph, and that's what it will not have that symmetric matrix.
Okay, sir, we can go to the next.
Yeah, we'll go. I mean, it's already 9:30. We may not. By the way, yeah, just a heads up. If we are not able to cover all the problems during the session, it's fine. All the slides and this problems will be uploaded on the portal, and you can solve all these at your own pace. You can change the slide, and I mean, there's two ways to do this, either as a instructor paced activity or student paced activity. So it will be uploaded on the portal as a student paced activity. So you can change the slides on your end. You can do it yourself. Whatever I'm doing from my side, you can do it on your end. Okay. So
sir, will it be in the supplementary content, sir?
Yes, it will be there in the supplementary. It's already there for previous.
Yes, sir. Yes, sir.
Yes, so it will be added over there. So don't worry in case if we are not able to cover all problems, you can go through them later on. Because I don't want to delay the session beyond a limit. It's already in a late night session. So we'll close at 10 maximum. So please go through this problem 3. quiz 2 session, I think it went beyond 11 o'clock or something. We don't want to do that for this session. That was something very critical for quiz preparation. So we did that, but this is a standard regular session. So let's try to close it at the scheduled time. So please go through it quickly and cover as many problems as possible. This is a follow-up to that. So not much of a change. Same co-star matrix we are using.
Where to enter the answer, sir?
No, the question that I will come to that. If you have done reading this, oh, okay. There is no way to submit the answer, huh? Oh, okay. I think there is some that particular fear deck thing, I think, got misplaced. Anyway, it's not there, so we can save that type. You can keep your answers ready with yourself, and maybe somebody can tell me what you think, what the correct answer is. Yes, anyone would like to pitch in?
So popular is the star who has worked with maximum number of co-stars.
Right.
And max is the number of co-stars with which he has collaborated with.
Right. So assuming that, can you tell me with this example, okay, whatever graph we have over here, what will be the answer?
Popular will be 2, sir.
Popular will be 2.
The max will be 3.
Right, max will be 3. Okay. Why so? Because
2 is the actor who has worked with maximum number of co-actors, and he has worked with 3 co-actors, so the max will be 3.
Yeah, just hold on for a second, Siddharth. Yeah, so as Siddharth was pointing out, right, that's correct. That's what will happen. But anyway, we'll, instead of directly jumping to the to the final answer, let's see what the solution is, right? So that's the pseudocode what we have, and as you can see, some minor changes are there into, or some different calculation we are doing based on that same matrix which was constructed in previous question, that co-star matrix, right? So what we are doing, if co-star of ij is greater than 0, we are simply incrementing the count, right? So this count will be incremented for every j. For a specific I, every time j updates, we are checking whether it is greater than 0. If that's the case, we are incrementing count. That means we will get some specific count for I. That means for every row, we will get some count. And if that count is greater than max, then only we are updating max and popular. Okay, so if you look at this, we are not interested in specific cell of the particular matrix. We are interested in entire row of a matrix, right? Because as you can see, this if is inside this j, and even this if, the second if block, even that is inside this outer for each. So for every I, we will be computing this, right? So that's the point to note over here. So we are now, in this case, we are interested in entire row. Okay. And what entire row represents? Entire row represents how many times I have worked, the actor I have worked with various different actors, right? So how many co-stars that particular person has. So if it is greater than 0, we are again not interested in what the number is. If it is greater than 0, any value, 1, 10, 100, doesn't matter how many times I and j have worked together. If they have worked together, we are incrementing the count. Okay, they might have worked once, they might have worked 5 times, they might have worked 10 times. Irrespective of that, we are incrementing count. That is the point to note in this first if block. All right. And later on, once that is done, we are finding that max and popular. That's pretty standard stuff.
So
for this pseudocode, we require the entire matrix. If we don't have the lower part of the matrix, we would not be able to do this pseudocode.
Yeah, you can. I mean, you will have to, change it a bit.
But we already know, no, sir, that who is like 4 times or 5 times. So we can do by that. So
yeah, I mean, in that sense, I mean, what Siddharth is saying is different. But say if Siddharth, you just have that upper triangular matrix, right?
Yes, sir.
Then pseudocode you will have to change.
Yes, yes. You have to consider IJ and
just alone saying IJ will not help. I mean, you'll
Yes,
have
yes.
to do a lot more than that, right? That's why sometimes it actually helps in storing additional information. It might look redundant at that point, but it may serve some purpose later on, right?
Yes, yes.
Yeah. Okay. So that's what we are doing with this, as I was explaining. And then if you look at this, right, earlier the maximum was 4, right? A particular cell has 4, but right now that's not what we are interested in. Now we want to know how many values are there in each row which are more than 0. So for this actor 0, right, actor 0 worked with 1 and 2. It might have worked 4 times, but actor 0 have worked only 2 times. I mean, the actor 0 has only 2 co-actors, right, which is 1 and 2. So how many such values, non-zero values are there in a particular row? That's what we are interested in. So that's why for
if number does not matter, variety matters. Yes, sir.
Sorry, can you repeat?
So means number does not matter.
Correct.
So variety matters. Like if
Yes.
he has acted
See,
with
I
various
might
actors.
correct. So what we are looking for, as you said, right, variety matters. That means how many different co-stars a particular star had. That's what we are looking for.
Okay, so yes.
Right. So I might have some star with me with whom I have worked n number of times. That's not important. How many such variety of co-actors I have worked with. Now that's what we are looking for.
Yes.
So that's why for first row, if you see, there are 2. For this second row, I mean the row number 1, again there are 2, 4 and 2. For row 2, 1, 2 and 3. For this there are 3, and for last again 1. Just 1, right? That means now this row ID number X is equal to 2, right? This is the highest we will get, right? 3, because the actor 2, he or she has worked with every other actor in our data set as per this example.
Yes, sir.
So that means that person becomes popular. I mean, that's how we are looking at it, right?
Yes, it has been explained in the lecture also.
Oh, it's there in the lecture also. Okay, but in some different context, I think.
Yes.
Popular student in the class or something like that.
Yes,
right?
yes.
Yeah,
but the same concept has been used.
Yeah, same concept is there, right? So that's exactly what we are doing. So over here it was 2. Again it is 2. Now it became 3. I mean, it's a question over here, but yeah, that becomes 3. And the last is 4. But by then the max is already updated to 3. And the variable I, or that popular, becomes 2. So our final answer is this. The count is on another column added. That count is 3, which is for 2. So max is maximum number of co-stars among all the stars, and a star with maximum number of co-stars. Right, and even looking at the graph, you can easily say a vertex or a node with maximum number of edges. So how many edges this particular actor has? Only 2 edges. This actor also has 2 edges. This actor has only 1 edge, whereas this particular actor 2 has 3 edges. That means he has worked with 3 different actors, and that's what we are looking for in this question. Is it clear?
Sir?
Yeah.
Yes, sir.
Sir, these nodes are talking about the rows, right, sir?
Yes, correct. Hello?
Yes, I got it, sir. Got it, sir. Rows,
Okay.
those nodes are talking about the rows and
Rows.
the edges are talking about the column.
Not exactly, but yeah, I mean, in a sense, yeah. In this reference, yeah, you can consider like that. Okay, so anything else, or shall we move to next? I mean, we can, I think, yeah, we can easily have one or two more questions. Okay, let's move to next question then, which is problem 4 is again that co-star matrix is used, but some additional information is there. So don't forget what that co-star matrix is, okay? So that actors and co-stars, what we had earlier, please remember that. And on top of that, we have this particular question. Please go through it. It's nothing much, but yeah, go through it once. Okay, so have you gone through it? Is it clear?
Yes, sir.
So it's some procedure which we are supposed to write. I mean, you have to fill in the code. And to that particular procedure, we are passing these two parameters, right? Actors and co-stars. The same things, the same variables which we computed or which we had earlier, right? So actors is a list of stars and co-stars is that particular matrix. All right. So we move to next.
Yes, sir.
Okay. And now these are your options. And over here, you can now submit your answer in form of either of the options. I think it's very easy. So 30 seconds. I think that's enough.
Done, sir.
Okay, only 20 students have submitted so far. Others? Any doubt? Okay, so less
Sir,
than half,
can
but yeah,
can,
yes.
Can you go back to the question?
Yeah, sure. It's not, I mean, just read that second statement.
Okay, sir. Okay, sir. Please move to the next.
Yeah. Okay.
Yes, sir.
So
We're done.
Yes, sir.
done, right? Yeah.
Yes.
So let's see what people have submitted. Okay, what? Don't know what is this. Okay, was it a MSQ or something?
No, sir.
No, right? Okay, then this time it's presenting some different kind of a graph, but I don't know why this is coming. And
We can put integer value in it.
Oh, you get to type over there. Okay, okay.
Yes, sir. We need to
Why?
type the option number.
Okay, okay, okay. That's why it's considered as a numerical input. Okay, that's why it's okay. Fine. Yeah, this periodic sometimes do some weird stuff. But anyways, fine. I don't even know how to read this, but somewhere in the 1 and 2 region, it's towards 2. So the point is the maximum people have submitted the answer towards 2. I think that's how we should read it. But yeah, anyways, we will see. That's more important. I mean, it's pretty straightforward, but yeah, let's see. So what is happening? We are supposed to return true when if returns true if every pair of stars in this list have acted together in at least one movie, right? So if they have acted together in a movie, at least so we are passing another list, right? So every pair of actors, every pair, okay, they have acted together, then only we should return true. Else we should return false. So the return true statement was already there. If you see the last line of that particular procedure is return true. So we have to add a code which returns false, right? So that means obviously the option 1 we can eliminate just because of that, right? We cannot, there is no point returning true twice. There has to be some code which returns false. So it is between option 2 and 3. Then we'll now see which one is correct and so on. So yeah, this is something you can refer later. Okay. Option 2 and 3, right? So we wrote a code with option 2 and same code with option 2 and 3 is written, and then we'll see what's the impact and which one is correct, right? So what happens with this line? What happens with this? I mean, this is some additional.
Actually, it is for 2 different actors. No, so that's why it is I is not equal to
because if I become
because
equal
if
to J,
the same actor will be there, then how come we can say that he is acted with any other person?
Correct.
So
if
then coaster,
it will always return false, right? If we do not write this I not equal to J, the point what will happen, it will always return false, because ij will be equal, and as we discussed earlier, the principal diagonal will always be 0, right?
Yes, yes.
And because of that, it will always return false. Right? So we have to check I not equal to J. I cannot say I was a co-actor of myself. That statement doesn't make any sense, right?
Actually, that's how I think, because that's how I answered the question.
Yeah.
Because one cannot be co-acted with himself. So that's how. Is the correct way, sir, to do that?
Yeah, correct. That's what, right? You cannot say I acted with myself. Yeah.
But if there is an edge from I to J where I is equal to J, then how can we represent that in the graph?
Okay, so in that case, right, I is equal to J. That means you do not have 2 nodes to be say, right? You have actually 1 node.
Yes, sir. Yes.
So in that case, we have something called a self loop.
Okay.
But I mean, it doesn't have much of applications, but it's there. The property is there for a graph. It's called self loop. An edge which starts from that node and ends in that same node. Just a loop,
Okay,
right?
What is it called? Self loop.
It's called self loop. Yeah.
Okay.
Yeah.
Okay.
Okay. Okay, and as obviously self loop should not have any edge. I mean, it should not have any direction. It doesn't make any sense to have direction for a self loop. People sometimes they put arrows, but it actually doesn't make any sense in having that, right?
But yeah, it's not logical.
Yeah, it logically doesn't make any sense to have any direction for that self loop, because it's anyway self loop. Okay. Correct. So yeah, Himanshu and Sakshi are having some funny discussion in the chat. Yeah. So
yeah, it is not. It's a contradiction.
Yeah. So what Sakshi already answered the Himanshu's question, so that's good.
Yes.
Yeah. So okay, fine. So I guess this is what the difference is as we were discussing. The problem in option 3 is if I and j are equal, that means we are talking about that principal or diagonal of the matrix. It will always be 0, and because of that it will return false, and that should not happen because we are actually checking same person, comparing one person with himself or herself, which is not a valid thing to do. That's why option 2 is correct, which is what most of the students have submitted. I mean, this is a more detailed explanation of all that. Considering you will go through these slides later on without my background commentary, that's why all those things are already put out there on the slides. So if you want, you can go through those at later point of time. So as you can see, option 2 is correct. Okay.
Sir,
so yeah,
how
we
first
have,
option is not there? The costas ij must be greater than 0. Then it should be true.
see, the point is we are supposed to return false in the first place, right? Return true statement is already there. So it doesn't matter what logic is. We should not have another return statement.
Yes,
True,
sir.
right?
Yes, sir. Sorry.
Yeah, I mean, there is no point. There is no problem in having multiple true return
Yes, sir.
statements.
So we should have that setting that should get false. So otherwise, it's true.
Correct. Because this return true is already there, right? So
yes,
we
sir,
cannot
yes,
change
sir.
that. So your
Inside,
setting should be
inside
adjusted
condition
accordingly.
false. Yes.
Yeah.
Hello.
Yes.
Sir, if the last return, if we just write the code as a return will be false in the last, then option 1 will be correct.
No, then you'll have to change the conditions also, right? Now, there is a problem in that. You cannot return true immediately just because you found one pair.
Yes, sir.
You have to find whether everybody has worked with everybody else. If you return true inside this loop, right?
Yes, sir.
Then you will return when you find the first ever pair where they have worked together. That doesn't mean all have worked with each other, right?
Got it.
That's why in such a case, it's always good to have true outside and false inside.
Yes, sir. Yes, sir. Got it.
Got it? Yeah.
Thank you, sir.
Okay. So yeah, we have time. Let's start with question 5. I think we can even finish it off all. Okay. Because question 5 and 6 are very straightforward ones. But yeah, a lot of background information is there. So please go through it, read it carefully, because it will be useful for question 5 and 6. If you want, maybe keep a note of, maybe note it down in some short words, which will help you remember later on. By the way, this question doesn't even involve any pseudocode or something. It's very straightforward and easy question, but the context is something which you have to digest in the first place. That's the tricky part here, to understand this particular information on the slide. That's why I said read it very carefully.
Oh, sir, the second line of second paragraph.
Second point, this one.
Yes,
if an
yes.
invitee, yes.
Actually, I'm not getting what that's presenting.
Okay, what it says, if an invitee accepts the invitation, then he or she can invite exactly one other person by forwarding the invitation that he or she received to this person.
By an example, like if
Okay, so for example, I am the host.
Okay.
I gave you the invitation and
Okay.
you accepted it.
Okay.
Then you can forward your invitation to exactly one more person.
One more person. Okay, got it.
Okay.
Got it.
So it's like you have an option of bringing in +1, something like that.
Right.
Yeah. And again, that +1 can bring in +1. That's how it's possible. Yeah.
So does this mean that the invitee has to invite one person, or like it can?
No. There's an option. There is a possibility is there. It's not mandatory.
If there is written,
if he invites, he can invite only one.
Yes, correct.
Okay.
But provided he himself or she herself accepts it.
Yeah, okay.
Otherwise, it's not allowed. Yeah.
So the host can invite exactly one person.
No, a host can invite any number of people.
Yes, sir. Any number of people, but for a specific people, can he invite multiple times? I mean, multiple invitations.
No. Only one invitation will go to one person from the host side. Yes.
Okay.
And a unique invitation.
Yeah, that too a unique invitation. Correct.
Host is sending only one invitation to other person. If he accept, he can forward that invitation to other person. So that's how things going.
Yeah. So, for example, I am a host. I will send a message to all of you, right? You internally can forward that same message to each other and so on, right? So that possibility is there, but from host, it will go out to whoever the host wants. Only a unique message.
Yes. So, but you cannot send two messages to me, is it?
Yes, host will not do that. But internally you can, right? You might get multiple invitations from different people.
I can, yes, sir. I can get from different people, but from
not from
specific
host.
people
Not
I can
from
get. Okay.
Okay. Is this entire setup clear? So this setup is important. Without that, you won't be able to answer the questions. I mean, as I said, it doesn't have, it doesn't have any pseudocode, but yeah, it's purely graph-based question. But I think some pseudocode-based question is there with this particular setup in graded assignment, right?
No, sir, I have not gone through the graded assignment.
Yes, sir.
Yeah, I think there is some graded assignment question with a similar setup. May not be, I don't remember exactly whether it's identical or some version of this, but yeah, this host and sending messages and all that stuff is there in graded assignment.
I think context is the same, sir.
Yeah, context is same, right? Yeah, right. So that's why this question will not have pseudocode. It will help you or direct you towards the answer of graded assignment, but it will not give you the actual answer. So that's
Here, pair of attendees is row and the column. No, it is just a pair.
No, where you are okay. Given a pair of attendees, there is an age from I to J if and only if the following conditions.
So IJ represent row column or just a pair?
It represents a row column. So you should read it as I is a row and J as a column.
Okay.
Because this is not a symmetric, it's not a.
Yes, it's not symmetric and yeah, it's directed. That's what I'm
directed. Yes. That's why I say, right, there is an age from I to J. We are not saying age between I and J. We are saying age from I to J, right? That means there is a direction.
Yes.
Yeah. Okay. So shall we move to the question part?
Yes, sir.
Yes, sir.
Yeah. Okay. So the question is, it's very simple actually. You have to find out which of the following is a possible graph for n is equal to 7, as in there are total 7 people. Considering the previous setup, what we discussed, out of these 3, which one is a valid thing?
Sir, where is the
No, don't tell me, just answer it on the peer tech.
Yes, answer.
So there can be two answers, sir. There can be two answers for this.
No, only one answer. Look carefully. Look carefully, or maybe you have to read the previous slide again. I got the point where which one you are saying as answer, but that's not the case because there is a specific clause which was there in the
Done, sir.
Yeah. Okay, only 15-16 people have submitted. What happened? Others just joined and left for dinner?
No, sir.
So usually, I mean, it was a curious thing. I was curious about this. So what do you guys usually do when you have sessions from 8 to 10? You have dinner while watching the session or what?
No. After watching the session.
Okay.
Even if it is till 11, then we do after that.
Okay, good. So it's not just the instructor is hungry, even students are hungry, right? Okay, that's good.
Yes, sir.
Okay.
Actually, it's very helping like that, especially solve with instructor.
Yeah, I'm sure. I mean, this particular question will help you solve that particular question in the assignment.
Sir, I think question is same.
Yeah, the question context is same, but over there, I think some pseudocodes are also there, right?
Hello.
Yes.
Sir, I have a doubt. As we read the question, then if the two nodes S, I and J have a arrow, then there is each one send an invitation to a single one only.
Correct.
So, but here in the problem 5, we have seen that there are the arrow, just like in node number 2, there are 3 arrows. So it means that he sent the invitation to 3 people.
Correct.
He is a host.
That means 2 is a host, right?
2 is a host, right?
Host can send it to any number of people.
And you cannot send invitation to the host, right, sir? Am I right?
No, I mean, you can, right?
Okay.
You can, but host will not accept it again.
There is no point inviting the host
in
his
event. That is true, but ideally you can, right? Sometimes you may not even know who the host is, right?
It is happening in one of the options. That's what I'm saying.
Yeah, it is happening, but that doesn't make any sense, right?
Okay, I'm got it.
Yeah. So okay, let's move. Let's see what people have submitted. Yeah, maximum have submitted option A, which is correct. So option A, I think some explanation is there with slides or something. Okay, fine. Let's do it here. So option A, right? The 2 is a host who's sending it to these 3 people, and 1 is forwarding to 4, 4 is forwarding to 5, 3 is decided not to forward, and maybe 3 decided not to even, may not even have accepted, right? Who knows? Whatever might be the reason, and 6 forwarded to 0.
Got it.
So this satisfies whatever the information was available with us. Now, what is the problem in option B? Option B, 0 forwards to 2.
Sir, 6 to 0, sir.
Sorry, yeah, no. See, 6 to 0 is not a problem, right? 6 is actually not violating anything. 6 is allowed to give the invitation to one person. We never said that 6 may not even know 0 is host, right?
So, but
no, I'm saying this, sir, 6 to 0, 0 to 2, sir. That is the problem, sir.
Yeah, the problem is over there, right? So if you can assume the 2 is a host,
yeah,
then
2 has invited 6, sir. Okay, it is okay. Okay,
yeah.
Then 6 invited to 0 is okay, but 0 invited again back to 2 is the problem, sir.
Yes, correct. That becomes a cycle, right?
Yes.
Yeah, that is the problem in option B. Then
Sir,
somebody
sir,
was saying, yeah.
Sir, in option B, I have doubt. That suppose 2 is the host. So then why can't 0 send invite to 2 and also
Because
2 cannot accept the invitation?
Because 2 cannot
there is not mentioned that host cannot accept any invitation. Host can forward the invitation to any number of nodes.
Correct.
Any number, yes. Why option
Somebody was explaining it in between.
Yes,
Please
sir.
go ahead.
So,
Yeah.
because the host cannot accept any invitation, and the edge is always there if the receiving person accepts the invitation.
Correct. Exactly, but why host? Okay. It is mentioned.
Arrow is given, right?
Doesn't accept any invitation. Okay, sir.
Understood?
Sir, actually, yes, sir.
Yeah.
This concept has been actually once discussed in the lecture also. And
Okay.
Yeah.
And then option C, the problem is the 2 edges are there for 5, right? 5 cannot accept 2 invitations. 5 can accept either of these 2 invitations.
Right.
5 can send, sir, but it can't accept 2 invitations.
Yes. See, age will be there only, incoming age will be there only if the person accepts the invitation, right? So two incoming edges are not allowed for any node. In fact, 5 cannot send 2 also. 5 can send only 1.
Yes.
Right. So that's why the answer is option A. All right. And that's what we have explained in these slides. But yeah. Okay. So that's done. Now problem 6. Shall we finish this? Just a couple of slides.
Yes, sir.
Yes.
Yeah. Okay. It's related to that. It's same thing, same context. So no need to read. It's the same slide, the previous slide. So if you want to revision, then maybe you go through it, but it's the same slide. So the question is different now. Again, you can answer this on peer deck.
It is a multi-select.
Yes, it is multi-select.
Yeah.
Done.
Okay. Yeah. Only 6 people have 8, 10. Yeah. Go ahead.
Done, sir.
Okay, let's see what the responses are, because I think it should not take too much of time. 1, 1, 3 are correct. 1, 3, 4. I don't know why, but yeah, 1, 3, 1, 3, 2, 4 again 4, 2, 4. I don't know. 1 and 3, 1 and 3. Yeah, most have submitted 1, 3 or maybe just 1 or just 3. This is best. 1, 2, 3, 4, everything. Nice. So. Okay, so 1, 3 is the correct answer, I believe. Let's see whether that's the case or not. Okay, let's not. Okay, this is important. Okay, so what happens is person 2 sends out 3 invitations to person 1, 3, and 6. So that's message 1, message 2, and message 3. And as we know, the 1 accepts that and can forward that same message to 4. 4 can forward that same message to 5. So M1, that is the message 1, propagates from 2 to 1, 1 to 4, 4 to 5. Message 2 goes only from 2 to 3. And then message 3 goes from 2 to 6 and 6 to 0. So there are just only 3 messages. So now the question was, 1 and which of the following statements are true, right? So 1 and 4 have identical messages, right? So 1 and 4, because 1 has forwarded it to 4. So definitely they will be identical.
So
actually, I thought so a host can send same invitation to
no,
people.
It was mentioned, right?
Yes,
Host
sir.
sends a unique invitation to everybody.
if we want to represent this nodes and edges in graphs, so it will be directed, I know, but how we will do that?
Sorry, how we'll do what?
If we want to represent that same nodes and edges in graph by graph.
This is a graph only, right?
Yeah, sorry, this is a graph. Sorry, matrix.
Okay, matrix. Okay, okay. I got
sorry,
it. Yeah.
I was confused. So
No,
actually,
I mean it's fine. Understood. Yeah.
Yeah. So how will we approach to do that? So like
Okay. So in that case, see, for ij as in 2, 1, we will have 1 marked over there.
Yes. Yes.
But for 1, 2, it will be 0.
Yes. Okay. But it's
but it's not a symmetric graph. That's
symmetric.
How
yeah, it's not a symmetric. It's a.
So 2, 1 is 1, 2, 3 is 1, 2,
yes,
6 is 1, but 6, 2, 3, 2, 1, 2, all will be 0.
Yes, got it.
Yeah. So any doubt in this answer? Why 1 and 3 are correct?
No, sir.
No, right?
No, sir. Sir, in this graph, can it be possible that we draw one more node and that node is not connected to any other node?
Then that particular person is not part of this setup, right?
Yes.
I mean, unless and until the person has age, then that person is actually not related to this, whatever event is there for which these invitations are getting sent, right?
Yes, sir. So the host might send invitation, but he or she did not receive that.
Yeah, may not accept, right? Then the age will not be there. Yeah, that possibility is there, but then it will be an isolated vertex, right? Which is not part of the main graph.
Okay. Okay, sir.
Sir, I have a general query. Sir, here related to my course, today I got a mail that we should be seeing in my dashboard if I am eligible for end-term exam or not. But sir, quiz 2 score has not been uploaded. Will it be uploaded or it will be?
It will be uploaded today afternoon only. Today afternoon we have processed your quiz 2 scores, so it should be updated latest by Monday. I don't know whether they will do it on weekend or directly on Monday, but yeah, maximum latest by Monday it should be there.
Okay, thanks.
Yeah.
Sir, the response sheet is released, I think.
Is it?
Yes, sir.
See, usually we release it only after we process everything from our end.
No, my dashboard is not showing.
Okay.
Yes, sir, it is released in the documents for download.
That's there is released, but not the marks explicitly on the dashboard. That's
no, marks will come. Marks will come. But
yes.
This is the next step. See, once we so is there, before going to that direction, is there any question related to this question or this solve with a session?
Sir, I have a question for.
So yes, Gaurav.
Sir, in some questions, it is written it as multiple selected questions.
Right.
But the correct answer given is only one option. And
okay, again, I will tell you that. But before that, should I stop presenting? Is it the end of this particular solve with us? Anybody has doubt with whatever is there on the screen?
No, sir.
No, sir.
No, sir.
Okay. Yeah. So coming back to that, right? Yeah, it is absolutely fine to have one correct answer, even though the question is multiple select. There is a provision to select multiple options, but it's not mandatory that every time multiple options will be correct.
So multiple select should not be written there then.
Why? We are saying multiple select. I mean, it is there. That's how the question is framed. We are not saying that see, you read the statement again. We never say that the question has multiple answers. There is a possibility that this question might have multiple answers. It's up to you to decide how many correct answers are there.
Gaurav, yes, Gaurav, if there is 2 correct answer and you choose only one, then you will get 1 by number of correct answers. So that's how it will be calculated.
Correct.
Okay.
Sir, are we done with all the questions, sir?
Yes. We are done with solve with a session. We are done with all the questions. So if you want to leave, you can leave. Yeah. If you have some other doubts, general doubts, you can ask. I will stay back for a couple of
sir.
minutes.
Thank you, sir.
Okay.
Thank you, sir. Good night.
Thank you.
Thank you, sir.
Thank you, sir. Good night.
I have a question, sir.
Yes,
Omkar,
yes.
sir, I have a question.
Yeah, Vishwajit.
Yeah, sir. Actually, I have seen. Latest I have seen today that few more courses has been added, sir. So does that mean that the program, the BSc program, is being instead of 3 years, it is extended to 4 years, sir?
No, actually, it's a 3-year BSc program, right? The problem is there are many universities where you go for masters, right? They ask for 4-year graduation in order. I mean, that's the eligibility is that you should have 4 years of graduation to take admission for masters. Okay, just hold on. Yeah, so considering that, many students actually requested that we should have a 4-year degree program. That's why we added some more courses and given another option, right? Right now there are already there were multiple options, right? You can do only foundational level and get out of the program. You can do 1 diploma, you can get out. You can do 2 diploma, get out. Maybe you can do degree, which is BSc degree, and get out of the program. Now there is additional one more option added on top of that, which is that BS degree, which is 4-year degree.
Biswajit, sir,
because actually, sir, last time when we talked, sir, okay, so you said that we are planning to extend to 4 years. Extend it to 4 years.
Correct.
So is it been done, or it is in process?
It was long done. Only thing is we did not have formal approval at that point of time, which we have now. So in next few days, or maybe in Monday also, I don't know how much time it will take, but you all should get a formal announcement regarding that.
So in which where course is added, Biswajit, sir? I'm not.
Yeah,
go to the website.
Course, for example, last time it was deep learning, machine learning was there. Right now, I have seen market research or some more courses has been added. So
yeah, actually those courses may not be actually related to this BS program. Those courses might be offered at the degree level also.
Yeah.
Right. So I mean, as you keep going and you go upgrade yourself level by level, you will know what all courses you can enroll.
Okay.
So all the details, the fine details of that BS program are getting finalized. That's why you haven't received any announcement, because as soon as you get announcement, you will come up with 100 questions, and we should have answers ready for all those questions. That's why formally we have not yet announced it. Okay.
Actually, that's a great news actually for me.
Yeah,
I mean,
that's why I'm saying right now I can just give you this much. If you have any specific questions on that BS part, how it will happen, this thing, that thing, just wait for a few more days. We are working on those final details.
It is a good announcement.
But it is approved, so it's happening no matter what. Okay.
Okay. Sir.
Yeah.
Okay.
Okay. Then if that's the thing.
Sir.
Yes, Vaishya.
Sir, actually, I'm new to computer science. So can I have extra practice questions? Last time I have enrolled in statistics of the same program, and as soon as I reload the page, I will get new set of questions again and again.
Correct. See, that is possible only in statistics or mathematics, like a course where you change a number, you get a new question. But in a pseudocode, that's not possible, right? We have to sit and write those pseudocodes manually. I mean, we have to create those questions manually. Over there, the questions which you are getting, those are getting generated using some program, some Python script running in the background.
Okay, sir.
Right. That's why it's not possible with programming like course. It's only possible with mathematical courses where you change a number, the entire question changes. So that's not possible what you are saying with CT, but I believe you have enough questions available on portal for practice.
Okay, sir. Sir, also
that's more than enough is what we think.
Okay, sir.
Yeah.
Sir, also before quiz 1, we got bonus practice assignments for first 4 weeks. Will we get the same before our end term?
No, No, I mean, in-term is getting finalized now, right? It's based on whatever the eligibility is there, based on first 8 weeks or 9 weeks, something is there, right? So that will happen. Now you will not need that. That was
Okay,
there
sir.
for qualifiers and all, right? Now there is no point. I mean, you are already qualified student, right?
Okay, sir.
Yeah, so you will not need that. See, those graded assignment scores are not considered anywhere else. Your final grade for computational thinking will not be based on your graded assignment scores. Graded scale assignment scores we consider as a attendance matrix. Yeah, there is some component, that some minor component comes from there, but that's not the whole thing, right? The majority of the score comes from your quizzes and the interim exam.
Sir, what about that
Okay, sir.
GAA?
Yeah, that's what I said, right? It's very small component will come from there, right? I think some 10% or something comes from there, right?
Yes, sir. Yes, sir. 10%.
10% comes from there, but 90% is huge amount, right? Comparing to that 10%, that comes from quizzes and interim exam.
Not 90%, sir. 80%, sir.
No, I think it's no. It's 10%.
80% from it is given, sir. 80% from 2 quizzes out of my best of 2 quizzes, and including interim exam. And 10% from graded assignment and 10% from bonus. I guess.
No.
5 marks for bonus.
It will not be like that. Maybe you should read it again. It's 10% from assignments, 90 from all the quizzes and interim, and bonus, that 5 marks bonus is on top of that. It's not part of that 100%. It's additional. It's a bonus, right? So it has to be extra beyond 100.
Sir, suppose I have got 9.3 out of 10 in GAA, then will it be approximated to 10?
Yeah, I think I don't know exactly how the operational team will. How will you get 9 out of? See, every graded assignment is out of 100, right?
Sir, suppose my average score is like 93%, then out of 10 it will be counted as 9.3.
Yeah, I guess so. I don't know whether they keep it 9.3 or they make it 9 or 9.5 or 10. That I don't know, to be honest, how operationally they will do it, but yeah.
So because sir, in quiz one calculation, the score calculation, they are just approximated.
Okay, then that same logic will be applied to this as well.
Okay.
So whatever they do for quizzes and interim, right?
Okay.
Same thing will be done for this as well.
Okay, sir.
Sir, I have a question and a suggestion regarding mock.
Okay, yeah, Karthik, go ahead.
Yeah, see, this mock submissions, this is especially for the international students who are working class. The mock submission deadline is either clashing with the leading hours to the work or with the working hours.
Okay.
So is there any possibility to extend the deadline, the same in the case of graded assignment submission, like till 11:59 p.m. in the night?
Okay, see, I'll tell you the reason behind that mock exam, right? We want to give students a feel of exam. Okay. So it has to be open for some specific duration of time, 1 hour, 1.5 hours, depending on the exam and depending on number of questions. That's the idea behind it. If we keep it open for the entire day or something, it becomes just like a practice assignment, right?
See, last time, I mean, before the quiz 2, it was like that, right? It was open for some, not for, interval. It was open for a good session of time. I mean.
Yeah, I think there was some issue with the portal that time. That's why we extended the time that time. It was not available. It did not started on time or something. Some issue was there. That's why it happened. But usually we keep it open for 1 hour, 1.5 hours, something like that, maybe 2 hours max. Okay. And after that, it is always available as a practice assignment. It's not like we remove it, but
I understand. But in case, I mean, these students of a particular region have to really, I mean, attempt it as in an exam mode, like what you say.
Correct. But see, then we can't keep it configured precisely focusing on students in different regions and their time zones, right? Which is not a practical thing to do, right? So we do it focusing on majority of students which are in India. So I understand it causes an inconvenience, but somewhere we have to deal that, right?
So can it be
Okay.
implemented such like whenever you open the assignment, then the timer starts?
Unfortunately, portal doesn't have that capability. See, the portal is not designed to conduct exams, right?
Yes.
It is not designed for that purpose. We are using it for that purpose with these mocks and all. So that's functionality is not there. So maybe, I mean, as somebody also earlier suggested about flagging, right? Maybe I can suggest this also to the portal's development team. Let they possible, maybe, yeah. So we have alternate portal which we use for exams, right? We have actually online proctored programming exam. All the programming exams we conduct online through our portal. So, I mean, none of you might have gone through it, but from next term onwards, right, when you enroll for Python and all, you will go do all that. So that time you will know it is possible. So that is there, but that's a separate portal. Exam portal, we keep it outside this current portal. I mean, they has to be, right? Because in this portal you have access to the entire content. On the exam portal you will not be able to access anything other than exam. So that's how it's there. Yeah, but anyways,
sir, thank you very much
yeah,
for
so
accepting
Karthik,
the
I got your point. I'll keep a note of it, and anyway I was supposed to forward one more suggestion which I got initially. I will add this also along with that.
Thank you so much, sir. Thank you.
Sure, thanks.
Thank you, sir.
Yeah, thank you. It's almost 10:30.
Just one more query.
Yes, Siddharth.
You said that this course will be converted into 4-year course. Will we have to pass additional courses in order to get the degree in that course?
If you want to do 4 years one, then yes.
So you have
because
the
or else you can continue with your 3-year thing, get BSc degree and get out of it. That's also possible. It's not mandatory for everybody.
Okay.
You will get a choice whether to complete in 3 or go for 4th one.
Okay.
Yeah.
So.
Okay. Yeah. Yes,
Sure.
Shailaja.
Is there a difference between BS and BSc?
Okay, so it's basically Bachelor of Science only. If you Google it, you will find it out. But see, usually in European countries or the countries which were earlier governed by British, that's the place where we get this BSc degree. But United States, there is no BSc. They follow this BS structure. And usually the United States, their universities specifically ask for 4-year graduation. So keeping their requirements in mind, we named this as BS. Otherwise, it doesn't have much of a difference. They don't have BTech and everything. So their equivalent to our BTech, they have BS degree over there. That's why we named it so that it makes it easier for student during admissions for if they go for some masters in United States.
Okay.
Yeah.
Thank you.
Yeah, sure. Thanks. Okay, so let's close. It's 10:30, too late. Let's everybody go ahead, have your dinners. Okay, have your dinner. Okay, bye everyone.
Bye. Thank you, sir.
Thank you.